It's really great to be back here at Netnod, because a year ago, on this specific spot, a young man was standing, Ignas Bogadonas, and he was talking about 64-bit communities. And at the time, he was elaborating on some issues that operators faced, and he argued that we should perhaps change that. So after his talk, I approached him and I said, yes, let's do it. And like bloodhounds, we pursued this. And now, a year later, I am proud to present the results of what came out of that particular meeting. As you might know, BGP communities are a fundamental aspect in the management of networks. We use communities to expose features to our customers, for instance, to allow customers to traffic engineer, to lower the local preference or higher the local preference, or limit the scope within which a route is allowed to propagate. And not just NTT, these are some of NTT's communities, but basically every IP transit provider will offer its customers features through these BGP communities. And the standard is that the first 16 bits of a BGP community are the ASN of the network or organization that administrates the second 16 bits. So 16 bits are given to you by the RAR, so to speak, and the last 16 bits are for you to use as you deem fit. And without BGP communities, we would have never been able to scale the internet as far as we have today. Because before BGP communities, we used prefix lists to manage what we announce where. And you can imagine that with the routing tables being the size that they are today, they would have become quite unwieldy if we had to use prefix lists everywhere. But 32-bit communities, or classic communities as I like to call them, had a certain limitation, and this limitation was highlighted a year ago, namely when 32-bit ASNs were introduced to allow for further growth of the default-free zone, there was a small oversight. They upgraded ASNs that they now could be 32 bits, so that allows for, say, 4 billion something networks to exist in the default-free zone. They failed to upgrade the communities aspect. And you simply cannot fit a 32-bit value in a 16-bit field. It does not fit. However, for a number of years, there were a number of proposals on the table that claimed, we will take care of this issue, just be a little bit patient, it's coming. Unfortunately, that was not true, so we had to take matters into our own hands and kind of force a standard through the IETF. This standard is called Large BGP Communities, RFC 8092, and we managed to go from first draft to IESG approval for RFC publication in precisely 6 months. That is in the IETF a world record. But then again, this took a tremendous effort from a large group of operators. There were tens and tens of operators that chimed in and brought their fists and pitchforks and torches and said, this is what we want, and screw all those other solutions. In those 6 months, we also created a number of implementations that can be used for testing, for production deployments, or for compliance testing. But we'll get to that later. So this is the large community in a nutshell. Classic communities are 32 bits, large communities are 96 bits. And those 96 bits are divided into 3 fields. The first field is called the global administrator. In that field, you put the ASN of the network that is responsible for defining the subsequent 64 bits or subsequent 2 fields. And as you can see, it's a 32-bit field, so it fits 32-bit ASNs precisely. And it also fits 16-bit ASNs. So for the first time, 16-bit ASNs and 32-bit ASNs are now equals. Followed by the global administrator is local data part 1 and local data part 2, and they are for you to fill as you deem fit. But in this presentation, I'll give you some ideas that might help you develop your routing policy. Why this thing is not 64 bits is for the reason of the namespace. A year ago, we figured, if we double what we have, then we can replicate what we were doing all these years, but we can then replicate it with 32-bit ASNs. However, one of our well-respected members of the community, Rudiger Volk from Deutsche Telekom, pointed out, hey, if you're redoing this community thing, why not make it so that the namespace is actually clean? And what is meant by this is that with the classic communities, a lot of people, you often see this with route server operators, they start using private ASNs in the global administrator field because they ran out of community space. And there's this design pattern to use a target ASN as a literal value to instruct your network to do something. For instance, you might have a community that says, prepend 2 times towards that ASN, where that ASN, that number, you put that in that second field. So if we would have doubled the community size, it would have, again, encouraged us to use private ASNs in a place that should be globally unique. So by making it triple the size of what we have today, we can guarantee that everybody has 64 bits to play with, and those 64 bits fit a value plus a 32-bit ASN. So that's why it's not double, but triple. We can now avoid colliding with each other's routing policies. And a canonical way of thinking of this is me function parameter, where me is the ASN, for instance, 2914, colon, a number that identifies the function in the network, for instance, prepend twice, and then parameter, the third field is, say, an ASN of the target ASN, or is a location identifier, or is anything that you want. Thinking about large communities, it's like moving an oil tanker around. It's a tremendous effort, and it's more than just typing out a document and sending that to the RFC publisher. There's a whole ecosystem, there's a whole culture that we need to inform and encourage to use large communities. So this means we need to train our staffs to work with large communities, to look for large communities and figure out if they might influence routing policy decisions. You have to ask your vendors, all of them, all your BGP speaking vendors, when is large communities coming? When can I deploy this? And if we look at how you would actually deploy large communities, my advice today would be, if you have an existing routing policy, deploy large communities alongside it. If you're a stop network and you have no dependence, nobody is buying transit from you, then you may decide to just switch over and ignore classic communities. But if you're in the business of offering features through communities to others, I strongly recommend that for the next, say, 24 to 36 months, classic and large communities coexist. We'll get to the deployment timelines later. Another interesting fact is that well-known communities, such as No Export, No Advertise, or Black Hole, do not exist in large communities, because we did not want to duplicate functionality that is already working, is already deployed, and people are already used to. Why go through twice that? So whatever we end up doing, classic communities, at least in part, are here to stay for the foreseeable future. And I would really try to ensure that the routing policy is, has feature parity, in the sense that you offer the same things that you do with classic communities, and also do that with large communities. Do not let them deviate too far from each other to prevent confusion. So let's look at how large communities and classic communities could compare to each other and why they're so awesome. On the first line, you see an example from NTT's network, 65400:peer-AS. And peer-AS should be replaced with the target ASN to which you want to undertake the action. What is noticeable in, let's see, do we have a pointer? By switching, or at least also allowing large communities, we gain two awesome features. The first feature we gain is that the namespace now is clean. You can see here 65400 is a private ASN, and NTT essentially ran out of community space, so we started squatting on private ASNs. And the downside of doing that is that if we were to merge with another network or acquire some network or do some integration work, there is a chance of collisions, and if communities mean something, if the same community means something different in that other network, we get unexpected results. But with large communities, we can just stick 2914: in front of the thing, and now it's in our own globally unique namespace. And that means that if we do M&As, then there will be no collisions because the acquired network will have done something similar and used their own ASN. The second nice thing is that because that third field is a 32-bit value, we can now allow this feature to work for 32-bit ASNs. While in classic communities, the feature only worked towards 16-bit ASNs. So that's two big operational issues solved with this new community style. Another example, the INEX, the Iris Neutral Exchange, offers route servers, and those route servers allow you to selectively export or not export towards certain other route server participants. They faced a similar problem. With classic communities, the feature only worked for 16-bit ASNs, and with large communities, they can now target 32-bit ASNs. So even if you yourself have a 16-bit ASN, like NTT, like INEX, 32-bit ASNs have impact on your routing policies. And that's why large communities are relevant to both 16-bit ASNs and 32-bit ASNs, because if you interact with 32-bit ASNs, the regular communities are too small. There's a document, it's 9 pages, called Draft IETF Grow Large Communities Usage. And similar to RC 1998, which was a companion document for classic communities, and that companion document highlighted some ideas of how to use this new communities thing, we have written a similar style document to inspire people. This is what you can actually do with communities. So I recommend that if you're interested in the topic, you type that in on Google or click in the spreadsheet slide deck and read that. What this document does is it describes a conceptual approach to communities in which we separate two fundamental categories of communities. On the one side, we have informational communities. On the other side, action communities. And we differentiate those because there's a sort of difference in directionality of the two. For instance, when NTT learns a route in a particular city or country, we tag that route with a community that indicates this route was learned in Sweden. And then when we propagate the route through a network and announce it to customers, customers can use that information to make their own decisions. So informational communities, in essence, are communities set by NTT and announced to others. Whereas on the opposite side, there's action communities. Those are set by our customers, and our customers set action communities because they want NTT to do something in the network. And that's something, can be all kinds of things. But they announce the community towards NTT, and then NTT is supposed to do something with it. So that's why we separate the two, because they have fundamental different properties in how you develop your routing policy. So informational communities, for instance, could refer to the ISO 31661 numeric country ID. The nice thing about that is that you don't have to invent a list of country name unique identifier yourself. You can just copy-paste from existing sources. Similar for geographical regions such as Africa, Europe, North America, South America, there are also existing lists and conventions which numbers belong to such constructs. What we can also describe with informational communities is, for instance, the relation over which we received the route. If we receive the route from a peering partner, we attach a different community than if we receive it from a customer. In all instances, the global administrator, in our context, is NTT. It is our namespace, and we document publicly this community means this. And if the community starts with 2914, then you know that ASN 2914 is the ones that are responsible for documenting that. So these are a few examples. From that ISO list, there's the Netherlands, which has been identified as 528. So what we do is we take that ISO-defined value, stick it in the large community, and call it a day. And what you'll notice here is that the middle column, that's what I referred earlier to as the function identifier. So if it's 1 in the middle, as an example, we could say, well, whatever follows in the third field must be an ISO country identifier. And then AS64497, who is the owner of the namespace, it is their responsibility to document that. A different function identifier is identifying the continent on which the route was received. And in this instance, this network chose to assign number 2 to that function. So it's function parameter. And to finalize the example, we've assigned function 3 as the function identifier to signify what the relation is with the partner or customer over which the route was received. And then in the fourth column, we assign numbers to each type of relation. And with this approach, you're burning tons of space, so to speak, because there may only be 4 types of relations, but we can do up to 4 billion values in that field. On the flip side, the middle field is also 32 bits, so we can have 4 billion different function identifiers. In other words, there's a shit ton of space to play with. Further examples, this was an interesting one that I heard from an eyeball network. Apparently, this network announces very small blocks to CDN caches to offer a highly granular insight into where eyeballs are located. So they'll announce up to, say, /25 or /27 IPv4. And this would normally not be visible in the default free zone because such small prefixes do not carry very far. But what they could do with large communities, something that is impossible with classic communities, is, for instance, just stick postal codes in the community itself. If you look at British postal codes, they're roughly 31 bits. You can encode the postal code as base 10. If you convert from base 36 to base 10, an integer rolls out, and you can just put that integer in the community itself. Or you can even go crazy and take the GPS coordinate of where you received the route, run the GPS coordinate through this algorithm called GeoHash, with precision 6, which means you get up to 600 meters of precision. You convert the geohash, which is a base 32 value, to base 10, and then you just stick it in the large community. So this opens up new possibilities that were not previously available, because if you have to stick this type of information in a 16-bit value, that's not going to work. So you have 64 bits in total to play with. Action communities, those are the communities the provider receives from other interested parties, parties that want the provider to deviate from the normal behavior. And in deviating, we could talk, for instance, about propagation characteristics, the local preference in specific regions of the world, or the amount of prepends. On the right side, you can see the example where literal ASN values are used in the BGP community itself. So if you would want to make a policy that says, do not export to AS65551, then you can quite easily code that in the large community itself. In this instance, the number 4 is chosen as the function identifier, ASN-based no export. If we want to do location-based export, we take a new function identifier, and then we can use those ISO values that we saw earlier, 528 signifying the Netherlands, so we can quite easily program, do not export this route to eBGP peers in the Netherlands. And because you can use all these values as literal replacements, you'll notice that your routing policy will be quite short. For instance, the ASN-based export on OpenBGPD is 1 line, because it contains a trick to refer to the eBGP neighbor. So with 1 line, you have suddenly created a quite advanced traffic engineering trick. If you want to get started with large communities, there's a bunch of resources that you can go over. There is a whole bunch of presentations. Most of them so far have focused on the process of getting from a draft to a standard, but now we have the standard. We need to focus our efforts on deploying large communities, and that's where this one came in. There's a bunch of BGP speaking implementations that already support large communities. I'll provide you with a list in a second. And there's configuration examples attached to the end of this presentation. If we go over the vendors, let's start with a few big ones. Cisco committed to providing support in iOS XR. They finished their beta code and were somewhat expecting that iOS XR 6.3.2 will have large communities in a production quality long-term maintenance release. So this means that early 2018, maybe-ish, who knows what their release schedule exactly will be, we can deploy this in our networks. ExaBGP, an open source project, was the very first one to support large communities and has been supporting large communities for the last half year. So if you're running DNS servers, and those DNS servers inject the prefix into upstream networks, I cannot read that, man. Okay. ExaBGP supporting large communities is very useful for the Anycast people, because as Anycasters, you might need to do a lot of traffic engineering, and you've seen from the examples that it is to be expected that with large communities, traffic engineering features will take a new turn. Juniper is probably releasing large community support later this year, as is Arista, as is Nokia. Both Quagga and free-range routing, FRR, already support large communities today. OpenBSD supports large communities, and the list goes on and on. If you go to the URL at the bottom, we maintain an up-to-date overview of all implementations that we're aware of. So if you receive new information from your vendor, please email it to us and we'll update the website. But with just updating routers, you're not there. There's a whole ecosystem to consider. And I think one of the best examples of that is PMACCT. Many of you use PMACCT to gather network statistics and analyze that and pump it into a database and use that for reporting. And maybe you're using PMACCT in the same way that we are doing at NTT, is that you match on communities to derive, did we receive this traffic from a customer or did we receive this traffic from a peering partner? And the fact that we're using classic communities in PMACT means that such tools also need to start supporting large communities. Fortunately enough, PMACT was one of the first to do so, but this means that we can match flow data that we receive from our routers, not just on classic communities, but also on large communities. And if you think back of the informational communities where we stick entire postal codes in the communities themselves, we can quickly see that the amount of granularity that we might have in our reporting can be increased because of large communities. But it's also debugging tools like Wireshark and TCP dump and BGP, that's a tongue breaker. But it's like a whole world of tools that indirectly have to do with communities that we use in our daily life. And all of these have been patched. There was a good effort, worth our time. If you want to take a look at a prefix that is carrying large communities today, you can type into your own routers something like show IP BGP, and then there's one of these prefixes. These prefixes are my house network, and they contain large communities. If your router does not support large communities, you'll likely see something like a hex dump like here, where it says, this attribute is not recognized, read this hex dump. If your router does support large communities, you'll see something like the below. The community attached to these prefixes is 15562:1:1. If you want to test large communities, there's a tool called the BGP Large Communities Playground, and it's basically a bunch of scripts and recipes to instantiate a whole Docker world where a lot of open source tools like GoBGP and ExaBGP are in Docker instances available to link up to things you want to test. And the regression testing approach that is demonstrated in this playground might be useful if you plan on testing your routing policies to verify if they're compliant with the intended behavior. We created this slide deck. We encourage you to recycle this slide deck if you want to share this information in your local community. There is no copyright. Just take the slide deck. We'll give you the master PowerPoint. And then you can put your name on it and start sharing this information. Because with large communities, like normal communities, which are basically the lingua franca between operators in the interdomain routing scene, it is of vital importance that all of us agree to use large communities. Because if we do not jump to large communities, 32-bit ASN operators are somewhat screwed. 20% of the default free zone is from 32-bit ASN. So they're already today a significant portion of the routing table. And most of the RARs are scraping the barrel, the bottom of the barrel for 16-bit ASNs. IANA, the actual source of ASNs, has run out of 16-bit ASNs. So what I'm hoping is that the popularity and rise of large communities will precisely cross over with us running out of 16-bit ASNs. Well, I advise that you take a look at these in your own time. Are there any questions so far?
So, hi, I'm Elm Jobbeck from Netnod. First of all, thank you to you, Job, and I know there has been quite a lot of people here in the room that has been involved in making this actually happen. And I think this is, as you said, a really good cause to have fairness between different ISPs on the internet. My question is more about curiosity, and also keep in mind it's been quite a while since I actually knew how to spell BGP, and the routers and memory and CPU power was much different back in that time. But my question is, are you aware of any simulation on what happens if you put on like 4 or 5 96 more bits of metadata on the routing information base if this happens for the full default-free zone as we know it today?
I've been running large communities on BERT in a hobby network I maintain in Amsterdam. And for every route, we attach not only classic communities, but also large communities. And I've not applied any scientific measurements, but I did not notice any difference. And I attribute this, in fact, to, like, for our perception, large communities are gigantic. But for a computer with, you know, even my cell phone has 3 gigabytes of RAM these days, a bunch of 96-bit values attached with a route, it's not that big. So I'm not worried. I've not heard any reports of people worrying about this. I think it's a more relevant question when we start doing BGPsec and attach significant portions of cryptographic material to each route. But in comparison, large communities are actually quite small.
Okay, I think we're running a little bit short of time, so if there's any further questions, will you be at the social tonight? Or?
Yeah, I'm going to the social tonight, where we can celebrate that now for the first time, 32-bit ASNs are first-class citizens as well. Thank you.
Congratulations.